Alright, so today I'm going to talk a little bit about one of my toys, part of one of my collections, in this case vintage audio equipment, something I don't cover very much in YouTube videos. This is a wire recorder dating from just around the end of World War II. Just a bit of a history lesson here while I'm showing this from different angles. As early as the late 1800s, probably around 1875 or so, people were thinking about taking telegraphy and finding ways to record it. Now, they could record simple Morse code type of telegraph signals using the equivalent of a phonograph type technology, but by 1878 an American engineer named Oberlin Smith proposed recording telephone signals onto piano wire. And this was a good concept, but in order to make it work they needed some sort of electronic amplification, both for the microphone signals or incoming signals, as well as amplifying the weak signals coming off of the magnetic heads. And they simply didn't have that technology yet. In the early 1900s, the advances in development of vacuum tube amplifier circuits allowed progress to be made in this area, and by around 1930 the first successful wire recorders were available. They were used quite extensively in World War II for military purposes, and also for sending covert messages on small reels in secret to, for example, underground fighters and so on. They weren't interceptable by radio, which was the only real other option at that time. After World War II, for several years, wire recorders became really popular in America and in Europe, primarily for business. They were used a lot for dictation and purposes like that, somewhat in the medical field for keeping records and for speech therapy, and they became popular in the homes, at least in the more affluent homes, to record music and radio programs. However, for example, around 1946-1947, these things cost, even a fairly small unit like this cost around $150, and that would be like $1,600 in today's money, so it wasn't a trivial purchase. This is the air vent here for the vacuum tube circuit, and all the vacuum tubes are immediately under this vent. And the back side only has a ventilation grill and the AC power connector. And there's really nothing else on the outside of this. It's quite heavy. I don't actually weigh it, but it's feels like you're carrying a suitcase full of anvils around. Very heavily constructed. Two latches. Allows the top to come up and detaches. Inside the lid is a set of basic instructions, especially how to take care of the recording head and how to avoid tangling the wire, how to do rewinding, and how to use the microphone. There are storage hubs for up to 3 rolls of wire, and this is a typical roll of wire here. This one's made by Webster Chicago. That's one of the leading brands. And a typical roll of wire like this, these were 2 3/4 inch diameter reels, and something on the order of 1/2 inch or a little bit more thickness. And the wire on here is basically steel wire with a high chromium content, which inhibits rust. Some people say these are stainless steel wires, but I haven't found anything to really substantiate that. Many stainless steel alloys, if not most of them, are poor in terms of magnetic properties. and I don't think they would work out as well. And most of the authoritative sources I found said that these are just plain steel wires like piano wire, but with a higher chromium content, which inhibits but does not prevent rusting. A wire reel of this size could hold up to 7,200 feet of wire, and the standard speed was 24 inches per second, much higher than we usually see on tape recorders, and that was necessary to get any meaningful audio fidelity. And if you do the math, 7,200 feet of wire at 24 inches per second comes out to 60 minutes, so you could actually get 60 minutes of sound off of a small reel like this. Typical reel had a silk strand, or almost a piece of sewing thread, sewn onto the end of the wire, or tied onto the end of the wire, to act as a leader, because actually handling the wire was very difficult. It's again, it's like a human hair thickness. It's very hard to see it when you just have a single strand, and it's very difficult to handle with your fingers. It's just difficult to manipulate. You can't get a grip on it. I should point out that wire of this sort can break or be cut for splicing, and splicing is simply done by tying a square knot and then pulling it very tight and cutting off the excess. And because the wire moves at 24 inches per second, even if you lose a couple inches or so in making a splice where there's a wire breakage, you hardly notice it on playback. The other thing that's inside of this is there's a hatch here which contains the power cord and a crystal microphone. These will work with other microphones, but the microphones of the day tended to be crystal microphones. This has a proprietary connector on it. And at some point somebody made up an adapter cable for this. I don't know if it originally came with it or not, but it adapts what would have been a standard audio type connector before the advent of RCA cables and or connectors and so on that we're more accustomed to today. This was a more common style of audio connector. So if I ever wanted to hook up an external device to this, I could just study how it's wired into this connector and make up my own adapter. Otherwise, I've just got a few odds and ends in here. The wire recorder, as I said, was popular starting right around the end of World War II and continuing up until the point when magnetic tape recorders became more popular. Even though it was essentially pre-war technology, it was really just coming into the consumer market around the end of the war, and so it persisted for a better part of a decade before it was replaced by magnetic tape. Now, the whole process of magnetic recording, I don't want to explain it all here, but everybody knows that with magnetic tape, you essentially have a bunch of very fine ferrous particles, essentially small particles of material much like iron rust, and in many cases that's what it is, bound together, and you can change the magnetism of each individual particle according to the pattern of audio signals that are applied with a magnetic head to the tape. And this allows a very fine magnetic pattern to be made on the tape, and this is why tapes can work at a slower speed. But when you're just recording on a continuous band of wire, if you tried moving it that slow, you wouldn't get anything intelligible, and therefore you have to really move the tape at a much higher speed, or the wire at a much higher speed. And it's interesting to note that not that long after this, I don't know exactly when it was, you know, the 60s or so on, the BBC, for example, had essentially almost a wire recorder for recording television video signals. I think it was more like a metal band than a wire, probably more for durability than anything. But those things were on humongous reels, and they moved at such a frighteningly large or high rate of speed to get the bandwidth necessary for a video signal, that if the wire ever broke, the wire whipping around could just tear people to shreds if they were in the area. Quite dangerous machines. This wire recorder is a lot safer to use. I don't know if anybody who's watching this video may have ever seen the great British TV show called The Secret Life of Machines, where they did grassroots demonstrations of basic technologies that were the core of most modern machines we're familiar with in the house and business today. And their episode on magnetic recording, they essentially took a bolt and wire and rolled a some zip cord around it and made a very crude electromagnetic, and they tied that into, I think, the output of an audio amplifier where the speaker coil would usually go, and they held this up to a metal bandsaw blade and were able to record barely discernible, barely intelligible voice. So that's really the same concept. Obviously they didn't have the speed there, so the fidelity and the frequency response was very poor. But one of the things that was figured out to make audio recording on magnetic medium work better was to bias the signal. So instead of just using the strength of the varying magnetic signal from the audio as the only thing magnetizing the wire or the tape later on, they biased it. So they would start with a certain amount of magnetic signal and then modulate on top of that with the audio signal. And this resulted in practical recording, but it had very low fidelity, very high noise, and lots of distortion. And by the 1940s, however, they'd figured out that if you used AC biasing instead of DC biasing, it worked much better and you got much greater fidelity and lower noise. And indeed, machines like this one use a 40 kilohertz AC bias. And since that's much higher than the maximum audio frequency these are capable of, I don't think you even had to filter that bias out when you played it back. It was just not audible. Of course, on modern magnetic tape recorders, they have to filter out the bias on playback. Wire recorders actually hold up very well over time. Magnetic tape, of course, would work well, but the plastic material, which is the substrate, tends to degrade over time. Heat, moisture, and so on, it comes apart. Whereas the wire reels, as long as they're well taken care of, they last practically indefinitely. So in many cases, probably most cases, an old wire recording from World War II vintage will play almost as well now as it did when it was new. Whereas if you get a magnetic tape even from the 50s or so on, or 60s, it's often unplayable today. One more consideration I want to mention here is, because this wire on the reel is so fine and it's packed in there pretty tightly, it's very easy, if there's not enough tension on the wire, for the wraps to become loose, and then that encourages shifting of one wrap under another, and you rapidly end up with a snarled roll. Another thing is to try to keep the wire playing across it in a slightly angled pattern, like you'd roll up a garden hose, or the little bails on a fishing reel to reel up the fishing line in a slightly angular pattern to prevent it snarling. Same thing is necessary on wire recorders. And so this is the recording and playback head here, and it just has a groove in it through which the wire feeds, and the head is on a cam which is powered by the take-up reel, and the cam slowly raises the head and then drops away, and gravity just pulls it back down, so the head ends up moving up and down slowly by about the same amount as the reels are thick, and that encourages the wire to play back and forth across the reel as it unwinds or winds. and this generally prevents snarling. If this head bailing mechanism doesn't work properly, it can ruin a roll of wire almost immediately upon an attempt to record or play on it. So otherwise, what do we have here? We've got the source reel, which there's nothing even required to hold it on there. The reels just sit in place. And then the head, and then the take-up reel. And just like with magnetic tape, you just loop the end of the wire through a notch, and that holds it in place. Now, why is this reel so big compared to this one? That's because there's no pinch roller or capstan on these, as there would be on magnetic tape recorders, and that's how you get the constant speed. Here, the wire is very fine, and the take-up reel is very large, and even with 7,200 feet of wire coming off of one of these, when it gets on here, the difference in diameter as the windings build up on the spool is negligible compared to other factors, and therefore just running this at a constant speed gives you a nearly constant wire speed. So it's a very simple mechanism. The controls for operating the mechanism are like the simplest open reel recorders. Really just a stop, a forward and a reverse position, and that's all there is to it. The operator controls consist of a play record selector, in this case called record and listen, a volume control which works for both playing and recording, the proprietary microphone connector, which doesn't have to be a microphone. You could plug in the output of an MP3 player or something and it would work. It's pretty forgiving. A very crude, I think it's a neon bulb, and it basically just lights up when you start getting close to saturation. So if you see it light up a little bit, it means you're probably at about the right level for optimum results. This unit is capable of playing through a built-in speaker, which is right here, or sending an output out this, again, proprietary output jack. In position 1, the signal only comes out the speaker. In position 2, I believe it only comes out this jack, but as if it was an external speaker, so it's an amplified signal that can be sent to an external speaker. And then I think in position 3, it plays the speaker here and sends out an unamplified signal here, which can go into another amplifier, which can then go into another device, or it can be hooked into the microphone input of another device. And indeed, this particular recorder came with a reel on it, which has since snarled and had to be thrown away, and it was a recording between a base station for a power company with the supervisor conversing with a power line lineman over the radio, and discussing how they were going to be handling an issue with some of the power lines. Kind of a cool conversation. And it was very easy to tell which guy was local and which guy was over the radio, but they had this back and forth going on. It was clear that the machine was just tied into their radio transceiver, and the fidelity was quite good.
Stand by. I'll pull your leg. Okay. Now take a left. Bye.
After 11 o'clock in the morning.
At 11 o'clock. Okay, well, I'll call around after 11 then.
Okay, fine.
Okay. We're, yeah, and we found the telephone lines the same way. We thought probably we could track it there all right. Yeah. Yeah, well, I thought that I had told you about that. Well, you know, you and I walked up H Street one night there together, and you thought it all passed then.
Well, of course, looking. Or what thing?
Yeah.
I mean, a lot of times.
Now, a few words about this particular machine. I bought this on eBay for I think around $100. These go for all sorts of values from several $100s down to about $50. The less expensive ones usually don't work. When I got this one, it was advertised as working a little bit on playback. When I got it, the head bailing mechanism did not work, so it snarled the first reel I got almost right away. It allowed me to play it, but then on rewind it snarled it and it was ruined. A snarled reel is just about unrecoverable. And the mechanism in here was slipping and had an inconsistent speed, and it was extremely noisy, and it would drown out most of the audio unless you had it turned up to full volume. So it clearly had some problems. The head bailing mechanism not working. There was a lot of hum on it, and it was clear the electronics needed some help. And I was thinking of digging into it, but when I saw the rubber rollers inside and what bad condition those were in, and how much rust was on the mechanism, I decided to send it to a specialist. And through a museum in Arizona called the Southwest Museum of Engineering, Communications, and Computing, or Computation, I guess, in Glendale, Arizona, they have a really good website and a good web page on wire recorders and repairing them and their history and so on. And they referenced a place in Ohio that mostly repairs old Victrolas as the go-to place to get wire recorders serviced. And I contacted them, and those people said they had backed off and all they were doing nowadays was the Victrolas. And they said, well, in fact, they never fixed them themselves anyway. They sent them to a place in Columbus, Ohio called Juke Doc and fixed them under contract. So I just contacted Juke Doc, and those guys said, yeah, they do tons of that. They're primarily in the business of buying and selling, refurbishing vintage jukeboxes, but they also do tons of wire recorder work and are quite experienced in it. They have sources. They sent my microphone off for reconditioning. They went through the whole mechanism and cleaned it up and made it work perfectly. They recapped the entire vacuum tube circuit, both the electrolytics and the inline capacitors, so we didn't have that issue. They cleaned up the switches and the potentiometers and made it practically like new. They even touched up the paint in a few spots, and this grill cloth in here was very dirty, so I think they took it off and cleaned it and put it back on. Anyway, so I'm going to take the cover off here to show a bit of the mechanism. So we start out with this beautiful Art Deco cover, and by the way, this is a Webster Chicago, which was one of the leading manufacturers of wire recorders, at least consumer grade ones. And there were two very popular models. This is the model 80-1, which was a slightly later version of the model 80. They're very similar. And then this was obviously the portable model. Then they had a desktop model, which essentially had the same mechanism and virtually the same electronic circuit, the same look, but it was built in a non-portable case. It was designed to be a desktop unit that just sat there. They used, you know, all the same stuff, the same reels of wire and everything. So here's what passes for the shielded cable. It's actually a like a coil spring shield going up there. And here's a incandescent light bulb. It's a type 50 bulb, just runs off the vacuum tube filament circuit, and that's to provide illumination for the take-up reel. Since there's no tape counter on these, it's hard to tell when you're nearing the end of the reel during rewind, and so the light shines on there and lets you see it a little better. The drive mechanism just consists of a set of rubber rollers and cap stands, very much like on an early record player, that engage in different ways. So for example, this is the play or forward position, and that's the rewind position. So it's really just moving this one roller around. So it engages things a little differently. And there's also these arms that come out, and they have drag brakes on them with spring tensioning. And you can see they don't move a lot. So one of the things Juke Doc did is they got this all degrimed and cleaned up and re-lubricated. And I forgot to mention before that in addition to the other controls, there's a tone control, which is really just a, I think it's a high cut filter or a low pass filter. And it's also the power switch. There's an off position here. So when you turn it on, it turns on the motor and starts spinning the capstan in this roller here. And it also, if you continue to turn it, it changes the frequency response for the best sound. So that's forward or record position, also for playing. And that's the rewind position. You might wonder what these two buttons are, and they're just there to keep from inadvertently moving the lever. They don't have any other function. They're not electrically connected, and they're just a raised button on a spring that you have to push down in order to move the lever one way or the other past it. And there's also a fuse over here. And it's apparent here how the light bulb shines out through a little window onto both reels, actually, not just the take-up reel. So I've got this one reel here that I'm going to put on. And it's just laid down over the hub here. And it's fed through the slot on the head. And one thing that's important to do with these is always start with the head fully raised. And to do that, so the head is still going down. Now it's starting to come up. And I wait till it just starts to go down again. There. So that's the position it needs to be in for lacing up the wire. And then I just pull it around the take-up reel, feed it through this slot, and then tuck it under this little clip here, which if I can get myself coordinated working with one hand. There. And this button in the middle actually raises that clip a little bit to make it easier to get the wire under it. Okay, everything's laced up here. The wire leader is still going through the head, so I'm going to manually advance it until the actual wire goes through. There you can see the knot went through. I've got it selected to listen. I'm going to turn the volume up to about here, turn the tone control about to the middle, and I'm going to engage the run.
This is Paul making a test of the wire recorder. This is Paul making a test of the wire recorder.
see the frequency response isn't that horrible here. It's actually somewhere in the area of 200 hertz at the low end, after which it drops off so there's no low bass. And it goes up to maybe around 5 kilohertz on the high end, after which there's almost nothing. So that's a good idea what these can sound like. And this reel here has had a hard life. It's got a lot of kinks and so on it. And so there's some stuttering and glitches in it that wouldn't be there on a pristine wire. And of course this wire is old and it's seen better days. But it still is in pretty good shape. And the recordings are listenable. So I don't really know that there's a whole lot more to say about this except to rewind it now. And the head is always engaged even during rewind, so you can hear where you are. And in absence of a tape counter, that can at least maybe give you some idea where you are. You can find pauses in the music and kind of use that as an index.
This is Paul making a test of the wire recorder. This is Paul making a test of the wire recorder.
So you can tell there that by listening for where there was a gap and a change in the characteristic even at high speed rewind, I could tell approximately where the beginning of my recorded voice, which was made using this machine's microphone, I could tell approximately where that was and resume playback from there. And then when I'm done, I just lift the wire off, and there's a little piece of tape that was put on these that you can loop the leader around, much like this, to help keep it from unraveling in storage. Of considerable value to me in figuring out things about this wire recorder are that the operator's manuals and the service manuals are readily available online and through eBay sellers and so on, and places like the Howard Sam's Publishing Company in Indianapolis has their famous Sam's Photo Facts, and you can buy for a few dollars a download of the Photo Fact repair guide for recorders of this type. They have it for the basic Model 80, which is nearly indistinguishable from the 80-1 that I have. And you can see here that it substantiates that the original sale price on this was $149.50. West of the Rockies, it's $153. But this is the user's manual here, and it's gives you a whole blurb on why wire recording is so useful. Gives you the basic instructions for use, terminology, controls, available accessories, spools of wire, input cords, a record changer to go with it, microphones, output cord assemblies, a portable amplifier, then the basic operating instructions. Setup procedures, how to lace up the wire and get the unit ready for operation. How to deal with noise, broken wires, microphone technique, erasing a recording, overview of controls, step-by-step operating procedure. More information for dummies, I guess. It's very explicit. They figured people had very little knowledge of this type of equipment, so they really spell it out. A little bit of history on the wire recorders, uses and application of wire recorders, and basic circuit used for recording and listening, the output switch circuit, and the complete electrical schematic, useful for servicing, of course. And one can see from this that the circuit really is quite simple. Simple motor circuit, basically a rectifier tube, and it uses a non-permanent magnet. I believe it's a non-permanent magnet. Yeah, it's a field coil and a voice coil, so it doesn't have a permanent magnet. It generates the speaker field directly off of one of the rectifier outputs. And then you've got 3 amplifier tubes in there, and that's the whole thing. An oscillator coil for the bias, the record playback head looks like 3 coils in it, erase and bias coils, and then the actual audio signal coil. The neon bulb, that's an integral part of the circuit. I think it's also there for detecting the overload on signal, so that's your signal strength meter. Your volume potentiometer there in the middle, and the output connector, which can be set up in different ways depending on the 3-position switch. So that's readily available. And then this is the actual Webster Chicago service manual, which is different from what the Sam's Photo Fact has, although it covers much of the same material. Again, an overview, different adjustments that can be made, service adjustments, diagrams. Diagrams showing how the parts arrange in different modes of operation. Information on how to adjust the cams and the spring tensions. How to solve various problems such as rewinding too slowly, wow problems, spilled wire that may be tangled up in the mechanism, lubrication, and then some nice photos of the mechanism identifying all the parts, top and bottom of the mechanism, a complete parts breakdown, more photos, a complete parts list keyed to the illustrations, a stroboscopic disc that you can put on the take-up reel. As I mentioned in the rest of the video, there is no cap stand or pinch roller on this, so it's really just the speed of the take-up reel that governs it. So the strobe is built in, and how to make bending tools for some of the adjustments, and so on. And the Sam's Photo Fact repeats a lot of that information, and then has some additional information as well. So if you were to get into this type of thing, it's nice to know that the documentation at least is readily available. So I hope you like this brief tour of wire recorder.